Let's look at a couple more examples of using iterated integrals to find area between curves. So in this problem, we want to use iterated integrals to find the area of the region bounded by the graphs of the equations square root of x plus square root of y equal to 4, x equals 0, and y equals 0. So we want to try to draw this picture to determine which region we're talking about. I know x equals 0 is my y-axis, and y equals 0 is my x-axis. The equation square root of x plus square root of y equal 4, I want to solve for y. So I'll say square root of y is equal to 4 minus square root of x. Then y is equal to 4 minus square root of x squared. So y is equal to 16 minus 8 square root of x plus x. So it sort of looks like a quadratic equation in square root of x. So it's going to kind of have this shape of a quadratic. But it's going to stop here at the y-axis because I can't have negative inputs. So this is the region bounded by the curves. And I want to know this point of intersection and this point of intersection. So in other words, I need to know the x and y intercepts of the function y equals 16 minus 8 square root of x plus x. I'm going to go back to this form. And I know that for finding an x-intercept, I'll just plug in y equals 0. So I'll have square root of x plus square root of 0 is 0 equal to 4, which means that x is equal to 16. So my x-intercept is 16, 0. And in the same way I can find the y-intercept, I'm going to plug in 0 for x, so I'll have 0 plus square root of y equal 4. So y is equal to 16. So my y-intercept is 0, 16. Now, I need to set up the integral. So I'm going to draw my small rectangle. So it looks like the bounds for my integration in terms of y, the change in y is from the x-axis to the curve. So that's going to be from y equals 0 to y equals 16 minus 8 square root of x plus x. That's going to be integration dy. Then I need to multiply by the change in x. So if I choose an arbitrary point from here to here, it looks like my x can run from 0 to 16. So this is the integration I need to calculate. Integration 0 to 16 of integration 0 to 16 minus 8 square root of x plus x dy dx. So first of all, I'll integrate the inside with respect to y. Integration of dy is y, so this is just going to give me y, and I need to evaluate from 0 to 16 minus 8 square root of x plus x. Then I'll integrate with respect to x. And so that's just going to be integration 0 to 16, 16 minus 8 square root of x plus x dx. Now taking antiderivatives, I know that antiderivative of the constant 16 is just going to give me 16x. Then I have minus 8 square root of x I can think of as x to the 1/2. So if I add 1 to the power, I get x to the power 3/2. Then I'll divide by 3/2. So I'll multiply by 2/3. And lastly, antiderivative of x gives me x squared over 2. And now this I'll evaluate at 0 and 16. So I have 16 times 16 minus, this is 16 over 3 times 16 to the power 3 over 2 plus 16 squared over 2. And then, of course, I would subtract 0 plus 0 minus 0. So I know 16 squared is 256. Now the term 16 to the power 3 over 2, I can think of that as the square root of 16 raised to the power 3. So that's 4 to the power 3. 16 over 3 times 4 cubed plus 256 over 2. And since 4 squared is 16, I'm going to think of 4 cubed as 16 times 4. So this is going to become 256 minus 16 squared times 4 over 3, or minus 4/3 times 256, and we have plus 256 over 2. So first I'm going to combine these first two. So I could think of 256 as 3 times 256 over 3. So this becomes minus 1/3 times 256 plus 256 times 1/2. I know that 1/2 minus 1/3 is 1/6. So it becomes 256 over 6. Or 128 over 3. So 128 over 3 gives me the area bounded by these curves. Okay, let's do one more example. Use an iterated integral to find the area of the region described by, we have y equals 1 over square root of x minus 5, and we're told that x is between 6 and 41. So the graph of the function 1 over square root of x minus 5, I know that the graph of 1 over x has the shape of a rectangular hyperbola. Looks sort of like that. The graph of 1 over square root of x is very similar, except I just get this branch here. And now I have 1 over square root of x minus 5. That just means I shift this graph 5 units to the right. So I'm going to say, if this is x equals 5, I have an asymptote here. This graph also has an asymptote along the x-axis, so it's going to look something like this. And then the question tells me to find the area when x is between 6 and 41. So I can say 6 is here, maybe 41 is somewhere out here. So the area that I'm talking about is just this much. And as always, I'm going to think about my small rectangle here and set up my integration. So the change in y, it appears, is from the x-axis, y equals 0, to the curve, y equals 1 over square root of x minus 5. That's the change in y, and then I want to multiply by the change in x. If I choose an arbitrary x here, it looks like I'm between 6 and 41. So exactly the bounds that the problem gave you are the bounds for my integration in x. Remember that we can think of 1 over square root of x minus 5 as x minus 5 to the power minus 1/2. So this is integration 6 to 41, integration 0 to x minus 5 to the minus 1/2 power dy dx. The antiderivative here of the constant 1 of course, is y. So this becomes integration 6 to 41. I have y, and I need to evaluate from 0 to x minus 5 to the minus 1/2, then dx. So that will be integration 6 to 41, x minus 5 to the minus 1/2 dx. We'll do a simple u substitution, letting u equal to x minus 5. du is simply dx. But I need to change my bounds accordingly. So if my bounds for x are 6 and 41, then my bounds for u will be 6 minus 5, that's 1, and 41 minus 5, 36. So I can rewrite the integration as the integration from 1 to 36 of u to the minus 1/2 du. Then the antiderivative of u is u to the minus 1/2. I'm going to add 1 to the power. That becomes u to the 1/2, or square root of u. And then divide by 1/2 means multiply by 2. And I just need to evaluate from 1 to 36. So I have 2 square root of 36 minus 2 square root of 1, which is 2 times 6 minus 2, which is 12 minus 2, which is 10. So that answers this question. The area bounded by the curve between 6 and 41 is 10.